everyone. My name's Stephen. I'm a technical lead at EVRYTHNG. EVRYTHNG have a platform for the Internet of Things. Unfortunately, we're not hiring. So I'm going to talk about a library we've been building at EVRYTHNG over the last few months that I call the Distributed Resource Manager. That's a bit wordy, so we sort of codenamed it Stork. But I've published it to NPM as Distributed Resource Manager, so this is free for you to download and use now. So what is the Distributed Resource Manager? So it allows you to manage real-time cloud resources in a distributed and fault-tolerant manner. A resource can be a real-time connection to another cloud, or a URL that needs to be called when an event occurs. It can also be used for polling. The Distributed Resource Manager allocates these resources to instances of the manager and ensures they're reallocated when an instance goes down or new instances are added. Users of the library supply a function they want to be called when a new resource is allocated. So the idea behind the library is that it abstracts away the problem of the allocation and distribution of resources so that you as a user can just write the business logic for your application. So when would you use something like this? So as I see it, you'd want to use it when the following are true. You need to manage a set of resources that connect to a third-party service in some way. So you need to set up WebSocket connections, you need to poll another cloud, or you need to subscribe to something like Redis for events. These resources need to be handled in a distributed environment. And also you need to ensure that if a node handling a resource goes down, that it's then reallocated somewhere else. So before I go into a demo, I just wanted to talk about why we built this. We had a couple of integrations that we had to build in the EVRYTHNG platform to the Nest cloud and to the Honeywell cloud. So you're probably most of you familiar with Nest. Honeywell is also an IoT device company. Just very quickly before I talk about these integrations, it's probably easier just to understand the EVRYTHNG data model. So you can create various entities in the EVRYTHNG platform. So the main ones are things. So this can be a device like a Nest device or a Honeywell device. Properties that represent the state of this device. And then actions, which are events that occur on the device. So for the Nest integration with the EVT platform, this was the basic user flow. A user wants to synchronize their Nest thermostat with the EVRYTHNG platform. When a temperature change on the thermostat occurs, it should trigger a property update in the EVRYTHNG platform. And when a user wants to update the temperature through the EVT platform, an action's created, and this data is then sent to Nest, so the thermostat is updated, and that will in turn then cause a temperature change event in the EVRYTHNG platform. So this is a basic diagram of the user flow. So you've got a number of users. They will say, I want to synchronize the data in the EVRYTHNG platform with my Nest devices. So then the EVRYTHNG platform creates WebSocket connections to the Nest platform for each of the thermostats. There's also some other devices in there like Nest structures as well. But yeah, the WebSockets are then created and handled by the EVT platform. So we needed to make sure that we were going to have thousands of these WebSocket connections that we need to create. So we needed to distribute these connections amongst multiple nodes. And also, at the same time we were doing the Nest integration, we had to do a very similar integration with Honeywell. The only difference is that rather than a WebSocket connection, with Honeywell you poll their cloud API for updates. So it basically made sense for us then to have a common library that abstracted away the problem of these resource allocations so that then a user, all they need to do is just write the logic for connecting to the third-party cloud, and then they can just build that on top of the resource manager, and the resource manager does everything else. So then this is basically the final architecture. So the distributed resource manager will poll the EVRYTHNG platform for new resources that need to be handled, and then the manager sets up the real-time connections to the thermostats or any other device. So yeah, as I was saying, we use this library for Honeywell. This also came in useful for an integration we did with if this then that. So I don't know how familiar you are with IFT, but it allows you to do mashups between various services. So you can say, if somebody tweets, send me an email. If I post something on Twitter, trigger something on my Alexa device. So the user flow for IFT was a bit different, but the principle was still the same. We had to subscribe to, we had to manage a set of resources, which in this case were events in the EVRYTHNG platform, and then make sure we triggered the IFT actions when those occurred. So I'm going to give a quick demo of the resource manager now. So as it's the World Cup, I thought I'd do a shameless tie-in with the World Cup. So the scenario is that as a user, I want to see my favorite players' shots visualized during a match. There's an external real-time API that you can subscribe to for when shots occur. And the distributed resource manager will manage the players the users select, and then they'll set up real-time connections to this API. So this is my server, and then I've got a basic front end here. Right, so you can see the key at the top that shows the type of shot that was taken. So I've chosen to demo this using the Colombia v Poland match that was on about a week ago. So I've loaded in all of the players for each team on the right there. So now I'm going to start 2 instances of the resource manager. And then I'm going to choose my favorite players, and I want to see their shots visualized. So I'm going to choose Rodriguez, Falcao, Juan Cuadrado. Poland, I'm going to choose Lewandowski. I'm a bit clueless about any of the other Poland players. So I'll choose Piszczek. I think Piszczek's good. I'll just choose another Colombian player. So I visualized the resource managers on the right, so you can see that as I've selected the player, one of the instances of the resource manager then picks up that player, the resource in this particular case. So now let's say the match is starting. So I'm going to click this, which will actually play out the match. So rather than 90 minutes, this is 2 minutes. So you should start to see some of the shots come through at some point. I think in this match it took quite a while before there was a first shot. Oh yeah. Yeah, so you can see Lewandowski had a shot blocked. And then Cuadrado had a shot off target. Nothing seems to have happened for a while. Oh, yeah. So now some more shots coming in. So let's say we've had a lot of users, wanting to see their favorite players. So we're going to start another instance of the resource manager. So you'll see now that I've started another one, all the players have been reallocated, but we've still maintained all of the connections to the shot server that's sending through the shots. So you can still see some of the shots coming through. So Cuadrado just scored a goal. Rodriguez just had a shot. And then if I take out one of the instances, so let's say one of the nodes goes down, the players then get reallocated. And you can see the shots are still coming through. Yeah, and that's the end of the match. So how does the resource manager work? So it's built on top of a library called RingPop. So RingPop was developed by Uber, and it's a scalable, fault-tolerant application layer sharding for Node.js applications. So there's three main components to RingPop. There's the membership protocol, the hash ring, and forwarding. So in the membership protocol, when RingPop starts, it will create a distributed application, and all of the nodes in this application all know about each other through a TCP communication and a gossiping protocol. So if a node goes down, then the application knows that an instance is no longer available. It will then also set up a hash ring. So the way this works is RingPop divides a key space up between all of the nodes in the hash ring. And then if you give RingPop an ID, it will then say this resource should be allocated to this node, or it should be allocated to this node. And then finally, there's the forwarding. So if RingPop instance receives a request and the ID of that request doesn't hash to that node, then it will then be forwarded to another node. So the resource manager basically takes advantage of these. The resource manager takes advantage of these things to be able to do what it needs to do. So when you start an instance of the resource manager, it goes through the following steps. So first of all, it joins the RingPop hash ring. Once it joins the hash ring, it fetches a set of resources. By default, this is via HTTP. For each resource, it will check if the resource should be assigned to itself. If not, it then gets forwarded to another instance of the manager. And then it will call a user-supplied function for each resource it should be handling. And this provides the business logic for the application, such as opening a WebSocket or whatever. And then if any other instances of the manager are started, the existing resources get rebalanced amongst all the instances. And if any instances are removed, the resources also will be rebalanced. So you saw that during the World Cup demo. So the user-supplied function, it's actually an object that a user supplies in the config when they start the resource manager. So this is basically a TypeScript definition of what that, a TypeScript interface definition of what that object should look like. So there's the handle resource function, which is your main function for setting up your real-time connection. Handle failed resource is called if there's an error when you try to handle the resource. Terminate resource, that will be called when the resource needs to be terminated. So that's usually called when the resource needs to be rebalanced in the hash ring. And then handle failed termination, which is called when there was an error trying to terminate the resource. So just very quickly, I'll go to the World Cup demo that I demoed earlier. So this is the resource handler definition here. So you can see I've defined this handle resource function. So this MQTT.connect, this is what connects to the World Cup shot server. You can ignore this WebSocket connection because that was just something I was using to post updates to the front end. So when the client connects to the WebSocket server, it subscribes to the player that's been assigned to this resource manager. And when it receives an event, it posts that shot to the server. And then the rest of it's not particularly important. In the terminate resource, I'm just making sure that I close the WebSocket connection when the resource is terminated. And then this is how you start the resource manager. So you need to provide the ring pop options for your application. So you need to provide an app name and the host and port that the app runs on. And then also the ring pop hosts that, this is an array of hosts that this instance of the manager should connect to. And then there's various other options in there, like you've got options for fetching the resources via HTTP, and whether you want to poll for new resources and that sort of thing. So that's a quick walkthrough. So there's also a plugin architecture for the resource manager. So it might be that you don't actually want to fetch your resources via HTTP. Maybe you want to get them from a database, or you want to get them from a queue or something like that. So you can define your own plugin that will handle the resource fetching logic. So again, this is another interface definition for the plugin. So there's three methods you have to define: the setup function, which you might just want to set up the database connection. Then the fetch resources, which is the main function for fetching the resources. So this might be a database call to get the resources. And then tear down, where here you might want to close the database connection or something like that. Yeah, so that's about it. And as I said, it's available at NPM. Yeah, if you've got any more questions, speak to me afterwards. Thanks.